Hello, and thank you for attending the webinar today. My name is Debbie Brisbane, and I will be presenting here using RISA 3D for complex industrial design. Let's see here, starting out, let's talk a little bit about the products we have. Today we'll be focusing directly on RISA 3D, but as you can see, we have a lot of different products available: RISA Floor, RISA Foundation, RISA 2D, RISA Foot, RISA Masonry, RISA Base, RISA Section, and RISA Tower. Those are some of the products we have available, and if you have more questions or you'd like more information about any of the other products and RISA offers, please come see us at our website at www.risatech.com. Going forward here, let's start by talking a little bit about the things we're going to be discussing today. Complex industrial design is going to be what we're going to be focusing on in RISA 3D. We're going to be utilizing the tools that we have available in RISA 3D. Those tools that we'll be using here, starting out, will be the high-level generation tool. And we'll be building a circular tank with that high-level generation tool. We'll be using a lot of the things in that actual tool there. We'll be using cones with plates. That'll be a way to build a cone on top of that tank there. We'll be using circular discs with plates, automatically using that high-level generation tool. We'll also be using an arc to help develop several different things for our model here, our tank model. We'll also be using our append feature. That's going to be something available in RISA 3D that allows us to bring one model into another model. We'll also be using our selection tools with very complex RISA 3D models, three-dimensional. You're going to want to use these selection tools to help guide you through the model and select portions of the model and making modifications and working with all the different tools you have there. Selection tools becomes a very, very important on a large model. We'll also be using our spreadsheet functions. So we'll be working directly in the spreadsheet to manipulate the data and the geometry. And then we'll also be going through our graphical display and results. So we'll go through how to make a model here, but we want to actually show a lot of things about how to display that model graphically so that we can also understand our results, but also understand how we're modeling that difficult tank model. So starting out here, this is what the model we'll be building today will look like. It's got a lot of different elements to it. As I mentioned, it's going to be a tank model there with a lot of different circular portions of it, but also some nice geometry on the base here to help us see how to use that. Okay, so if we start out here, I'm going to jump into RISA 3D. We're going to hang on here. I'm just going to jump right into RISA 3D. And with RISA 3D here, we've opened up a fresh model. And what we can see here, so I'm going to just close down the starting a model. And in the very beginning here, what we're going to work on is we're going to start by creating our section sets. You'll notice in RISA 3D that we have our data entry toolbar floating around on the side here. That's going to be our guide to our model. What we're going to do is we're going to start by setting up our section sets, as I mentioned. Section sets are a way to really start your model and use the same type of member throughout a certain area. So for example, we're going to be putting horizontal members in our tank element, and that's going to be called an arc member. So we want to make sure that they're all the same and similar. So we can call them an arc member, and then when we go to resize that arc member, we'll end up resizing it all like the same way. So we can choose a shape here from our shape database. If I come in here, I'll see I have wide flange, tube, pipe, channel, WT. What I'm going to choose here is going to be a double angle, and I'm going to choose something maybe like a 5-by shape. You'll see he's got 5-by-5, so equal legs. If you scroll down to the bottom of this list, you see that it starts to be unequal legs. So I might do some unequal legs for my tank. I'm going to make it maybe a 5-by, let's see, how about a 5-by-3-by-6. So you can see the inner leg here is going to be 3 inches, and the outer legs are going to be 5. And then we have 6, which is 6/16. And then on that last number there, 0 is the space between there. So I've got that. That is my spacing there. And what I can say is okay. Now I'm going to use beam as the type. Wide flange is going to be the design list that's chosen automatically. That wouldn't work for us here. We want to choose as a design list a double angle. And what the design list does is it goes through here, it's saved on your C drive, and it's going to tell the program what list of members it should choose from for a suggested shape. So we want to choose a double angle if we're using a double angle shape there. I'm going to use A36. I'm going to push enter. I'm going to actually enter in the axis member. This is going to be our vertical members for the tank here. So if I say axis member, and this axis member, I'm going to click on WT. So I'm going to make sure here I can select hot rolled WT. And it looks like here I'm going to pick 15 by, let's see, let's pick a smaller WT and we'll kind of see where that goes. So we'll choose something maybe like a 12. That's a pretty big WT here, but we got a pretty big tank to start here. So this is going to be a vertical member, so I'm going to call it a column, and I'm going to use a WT here for my design list. Okay, maybe an A992 material for this. So I've got all these members in my section sets. Next thing I'm going to do here is go in and click on the high-level generation tool. So you can see it looks like a little black icon at the very top. If I click on that, what I've got is I've got the ability here to look through here, and I can see all the different things that are available in my high-level generation tool. I have a circular arc. I have parabolic arc. We'll be using the circular arc today in this model. We could use things like a 3D grid. What we're going to do here is pick out the cylinder with plates and stiffeners starting out for our tank. We can choose here, you can see that this tank here has a picture of all the different elements available that we can lay out in this tank. The first thing we're going to start here is our origin is 0, 0, 0. We can place this anywhere along in my three-dimensional model, but 0 works for us right now. We can do a whole 360 degrees, which is what we will do for our model, but we wouldn't have to. We could choose maybe 90 degrees if there was some other way we needed to modify that. Rotation axis is going to be Y, and that means that we're using this vertical global axis here on the left. We can see that. Our radius is we're going to be using as 30 feet. So the sweep angle here, that's the radius that we show here in this picture, and the sweep angle or increments here tells us how many increments we're going to go around in that's 360 degrees. So we're going to sweep around 80 times, which just gives us a 4-foot increment around that around that entire diameter. Our axis increments here, we can set this up to be 20 for our axis increments, which means that it's going to go vertically. This is the axis is the vertical portion here, which you can see this axis member. It's going to go 20 increments of that, and it's going to be an increment length of 1 foot. Okay, so this picture shows here a little bit submeshed inside of these increments, but we're actually going to go 1 foot increment, and then we're going to go up 20 feet. We want to generate some members, so you wouldn't have to if you didn't want to put these axis and arc members in, but we're going to put those arc members in so we can see arc member. I can drop it down. If I have the section set defined beforehand, it's easy for me to pick from this list. I can also rotate things if I need to. So I actually know this is going to be rotated by 90 degrees since I've already done this model before. But if you didn't know, what's nice about this is that I could experiment with this and it'll come back to the exact same thing I was working on before. So if I didn't know 90 was correct, it would actually remember what happened, what I did here for the next time, and I could work with that back and forth by pushing undo, undo, and OK. My plate elements here, I'm going to use general steel as my plate. The plate element here, I'm going to give it a 0.75, and we'll just take a quick look in the materials to understand what that means. And I can say OK. And I see that here that I have a tank generated for me automatically. So what I've got is my tank with my plate elements and my materials that I had already told there. If I double-click on a plate, it tells me here that these, oops, this is actually a member. If I double-click on one of my plates, I can see I'm using 0.75 general steel as my material set. If we go to our materials here quickly and can see what this material looks like, we see we have hot rolled, which is already selected for our members. We also have general shapes, and that's what your plate elements are going to be used here as general shapes. They're exactly the same as any other of the materials, except they really just don't have that last element, which is like the yield there. You can see you have general, you have all the different stiffness properties, the densities, everything that you need here for that plate. And if you don't have this, if this isn't quite your properties for steel, you could enter in directly there another type of shape for that. Okay, so we'll be using that general steel for our model. So I've got my cylinder all built and ready to go. Okay, I can look at here an isometric view. And what I can do now is just save the model here. Let me save here as a tank model. I'm just going to place this right on my desktop and call it tank. Here we see I have my tank final ready to go, but I have my tank starting out. And what I've got here is this is my tank model, and it's going to be, we can take this right into, it's ready to append it. We're going to build some stairs up it. But one of the things I do want to show you is I have some defaults turned on for my plotting, and I want to show you kind of these options here. If you click on these nodes, you can turn things on and off by double-clicking on these nodes a couple times or toggling through. And one of the things I have as my default is I turn the node labels off. And I just turned off show joint labels, and I said no labels, and I went over to miscellaneous and said make current settings the default. And I said okay, and now whenever I bring in a model, I'm not going to see those node labels. It's pretty distracting with a very large model. In a smaller model, you may be very important to see those node labels. The other thing that we have is a newer feature here is a customized tool bar for plates. So if you see here, I can scroll down and click on that plates. And right now I'm showing the X symbol. And if I click on that arrow one more time, I can show my labels and zoom in real close and see all the labeling of my plates. I also can turn on my local access, which will become very important when we load these plates later in the model. So I see here I've got local access turned on. I can even show the material, for example, if I had lots of different types of materials in one model, things like that. If you are not familiar with this customized toolbar, this is a new option we have. It's under Tools, Customized Toolbar. And we see here, and if I open up the customized toolbar, some of these things are going to be real important for our model. We're going to want to see the plate force contour. I'm going to add that, and I'm going to see the plate stress contours and add that. It says here not enough to fix since I actually have lowered my resolution for this model here to use on the webinar. So what I'll do is I'll take off my solid label. That one's, we're not going to have solids in this model. So I can just remove that. And normally if you're just working at your desk, you should have enough room to add a bunch of these on. So I'm going to turn off that, maybe turn off the member IJN, remove that, and you can customize this. One of the ones that's really important to me is the deflection one. I think that one's really a good tool to have on your toolbar. So I have all that set up, and I do recommend that you go to Tools, Customize Toolbar to work with your toolbar so you have that all customized for the way you model and the way things that you use very often. Again, so I'm going to save this model. I'm just going to click on Start a New Model, and what we're going to do is work on putting that staircase on. So if I say Start a New Model, we open up a brand new model. I'm going to just close it down. And one of the reasons why I like to show this is we get to use our append feature, which is a really good option. But I also get to show here that you've got sort of a complex model, and it's an easy way to start another blank slate almost, to start again and sort of, and then we can append that in. We'll see how easy that is too, is that even if it didn't line up properly, you could just shift it around. So I'm going to start a new model. Again, I'm going to use some section sets. So I'm going to come in here using my section sets. I'm going to call out here as a treads. I'm using, this is for a staircase, so I'm going to have treads. I'm going to have stringers, and then I'm going to have some posts, and I'm going to have some handrails. Okay, so you've got all those different options here for my section sets. I'm going to give myself some shapes that might be appropriate. Starting out with that tread, I'm going to pick out a channel shape. Let's say maybe we'll say a 10 by, let's say 15 as our tread. My stringer, I'm going to choose another channel shape. I'm going to scroll down maybe a little bit of a more decent here, maybe 10 by 30 we'll start out with. And then my posts, I'm going to actually change my posts to be maybe an HSS. Okay, so those are going to be what's going to be supporting that. So for my posts here, I'm going to choose, a tube shape. And the tube shape we're going to choose is going to be, let's say, so we'll see here again the pattern where it's 8 by 8 or even size for both sides there. Maybe let's choose a 4 by 4, for example, or how about a 6 by, let's see, I can scroll up and down. If you know exactly what shape, maybe a 5 by, we'll try that. If you know exactly what shape you wanted to do, you could just type it directly in, or you can go to this actual shape selection toolbar here to help you. For the handrail, maybe we'll use a pipe. I think that'll be an easy, maybe a 2-inch pipe will be helpful for us. And so we can say OK. We will need to change the design list to be channels. For the channels here, we're going to use tube shapes, and we're going to say pipe. Oops, click on that, and then we say pipe. We will sort of change some of these material types to something maybe more like the type of material we're using, and I can close that out. Okay, so I have all my section sets in place. The way we're going to lay out this tread here, the staircase, is using my arc tool. So I can go in and click on circular arc, and that was on my high-level generation tool. And what I can do is I lay out the arc just like we did the tank. It's going to be at the origin of 0, 0, 0. It's going to go from 0 degrees to 90 degrees. This is just going to go around a portion of the tank. We're going to use the rotation axis as Y, vertical, just like we did on the tank. The first arc, I'm going to make sure that that matches the actual tank radius. So that's 30 feet. And the biggest, most important piece of this is that we match the actual arc, increments. If we match the arc increments of the tank, then we'll be sure to line up with a plate element. So if I'm going to use 20 elements for my to match up with those 20 increments that we use vertically on our tank. Since we already have our section sets picked out, we can quickly grab this. So I'm going to use a stringer for my section set. Again, if you didn't have your section sets picked out, you can pick some of these default ones and then go back and work with it from there. You can say OK. And we see here automatically I've got this laid out here with my arc in place. The next thing I'm going to do is just lay out that outer arc. So I click on High-Level Generation tool, click on Circular Arc, and this time here I just click on Arc Radius being 34 feet. Everything else is remembered for me. This is one of RISA's greatest features, I think, is that when you go back in, everything is remembered for you. If you don't want it to be remembered, just push clear. It's no big deal. But it is nice to be able to go right back in and draw it right on the same spot and doing exactly the same thing with a little bit of a modification. So now that I've got my arc, my stringers in place inside and outside to match up with my tank, the next thing I'm going to do here is click on Draw Members, and then we're going to click on the treads. So I'm going to draw the tread in place. I'm going to say Apply and click on Draw the Tread. Let's take a quick look and see how that actually drew it. That's not going to be the way we're going to want to walk on that tread, right? So what we can do is we can just double-click on that and turn it to 90 degrees. And now if in this double-click menu, we can just say OK, and we see that it turned into 90 degrees. There's lots of ways to rotate that. You could have tried to remember it from the start, but it's easy enough to just double-click on things and change it. So now what we'll have once we've laid in that tread there, what I'd like to do is I'm going to actually draw in some line loads on that tread. So I'm going to first start by opening up basic load cases and creating some load cases here. So if I say dead load in my basic load case 1 and live load in my basic load case 2, one of the things I want to use is use these categories. It's pretty important if you're going to use the load combination generator later that you put in that category. If you are using something somewhat industrial that you really never follow our load combinations that we use for the load combination generator, then it really wouldn't matter. You could actually just disregard the categories. We'll see that here in a second. What I'm going to do is give myself some Y gravity, and that means that I'm putting self-weight on the model. So if I look at this, I'm going to be applying self-weight on the negative Y direction, which is downward. And so next piece I'm going to do is apply some line loads. So if I click here on the Apply Distributed Line Loads, I'm going to add a little bit of some line loads, so maybe a negative 0.02 kips per running foot. The negative means it's going to be downward facing, and I can say Apply and just click right on that first tread. And once I have that in place, what I'm going to do is I'm going to draw, instead of having to draw all of these treads in place, I'm going to unselect that model and just select only that tread. And the way to copy this all the way around the whole thing is to copy rotate. So if I click on Copy Rotate, say I can see here I have it 0, 0, 0 is my origin, just like it was for my arc. I can choose my rotation axis as Y. My angle is going to be 90 degrees. And then I can copy that 20 times because that was the number of increments that I had for that arc. So if I say also, it's really, really important to say copy load with the members. So as soon as I say that, Apply, I can see all my treads went across, and then I have actually all of my my stringers connected here with the load. So one of the things I did forget, though, right, was live load. That's okay. We want to try to manipulate some of our spreadsheets a little different way. So we can click on the basic load cases again. And once we do that, we can see the top of this actually changes its icons. So we see we get kind of a couple new icons in here. One's going to be clear all, just in case we made a major mistake and we need to clear the entire thing. We could clear the entire BLC. But what we're going to do is say copy one BLC into another. So I click on that, and I can see here I can copy from the dead load into the live load, I can have the joint loads, any of the different types of loading I can copy or unselect and not copy, okay, and say okay, and I see now I get 21 of those distributed loads right into that basic load case. Easy as that. Now maybe that's not the number we want to use in there, so what I could do is I can select the entire thing, and I could say right-click, fill the block, maybe with negative -0.004, for example, and I can fill that. Or another way you can modify a whole block is by clicking on the top, or of course by just selecting everything, and I can right-click and say math on the block. I'm going to do that this time, and I'm going to multiply it by 2. This is 2 ways to get the exact same effect here, okay, but just another way to show you how to do that. So now, when I go back to my staircase here, I see that I have live load and dead load, and they're slightly different loading here, but I have them both on those treads. So what I'm going to do is I'm going to grab my Excel spreadsheet from the side here, because one of the things you'll notice is it's flat, right? I haven't lifted that staircase. It's not really a staircase. It's just sort of a flat platform right now. So what I can do to lift that, there's a lot of different ways to skin this cat, but what I'm going to try to do is just say 0, 1, 2, and I'm just going to run here down. I'm actually going to, I just deleted that by accident, but what I'm going to do is just run this to 20 increments. Okay, so it's 0 through 20. We're going up by 1 foot increments, just like we had in our tank. I'm going to say copy, and I'm going to jump over here into my into my joint coordinates. And since everything is at y elevation 0, what I want it to be is every increment wants to go up by 1 foot, just like I had in my Excel spreadsheet. So I can say right-click and say paste, and I can pull up one side. So you can see just one side is being pulled up. So now I can go to scroll down to the bottom of that list and just right-click and say paste, and right-click and see that the other side went up. So this is kind of a creative way to go into Excel and pull out information that you want to manipulate. If there was some sort of a different, not just 0 to 1 to only 1 foot increments, that would be something that would be really easy to do in an Excel spreadsheet. And by copying and pasting right out of Excel, you can really make a lot of different geometry changes right in the joint coordinates. So it's very easy to do, and I think is a real easy and clean solution. So once I've got all of that in place, I've got my treads in place, I have my stringers, we've got our loading. The next piece I'm going to do is going to just be to draw in some posts. So I'm going to turn off the loading just so we don't get distracted. Maybe just go back out of there and turn off. So again, we're just modifying the way we see things. It helps us to draw things a lot easier. And what I want to do is put in some posts at 5, and then again at 10, and I can see the coordinates at the bottom right corner. If you can see your bottom right corner, I can see I'm going at 10 feet, again at 15 feet, and then 20. And I'm just going to drop some posts in those locations. So what I do is I unselect those nodes, and then I reverse the selection using this invert the selected state, and I see that I have just those nodes selected. And what I'm going to do is say copy. I'm going to copy them down by -5 feet. Okay, so if I say I copied them down by -5 feet, everybody looks good. Okay, they're all copied, but now these are not appropriately copied yet. So what I'll do is I'll unselect some of these joints, okay, and then I will move some of them, again, another -5 feet. So now I have some more copied down appropriately at the 0 location. And that might be long-winded if you have a lot, so what you could do even is just go in and say 0. Okay, or you could even go into the spreadsheet and go and say 0 in the elevation. But you can always double-click mountain joints. Sometimes when I only have a few joints to modify, the easiest way I find to do things is just double-clicking on that joint. So now I'm going to say draw new members. I'm going to click on hot rolls and click on posts, and I can say apply. I'm going to just draw in these posts. Oops, I clicked on the wrong spot. Sometimes that kind of gets away from you. And click on that there. Okay, and let's see here. We've got all of our posts in place. We will need to put our boundary conditions on those posts. So I click on Modify Boundary Conditions, say Fixed, and I can highlight the base of each one of these columns. Okay, so you've got your bases already in place and your posts and everything is ready to go. The last step I want to do in here is create some handrails. So what I will do for handrails is I'm going to use my selection tool, this kind of funny polygon shape, to create only that exterior line there. I'm going to grab this outside stringer, just like that. Okay, and I use this little selection tool, odd selection tool here, polygon. And what I can do is say copy. I'm going to click on the copy, make a copy, and this one I'm going to go up by 3 feet. So I'm going to use a positive 3 in the Y direction. Okay, and then the big thing I'm going to do is say interconnect those bays. I want to actually connect this. So I'm going to say apply. There's no load, so it's okay to leave that on. And now I've got my handrail in place for the exterior. One of the things I will want to make sure is I modify that handrail so it's not the exact same material as that stringer. So I'm going to unselect the stringer. I could actually use the criteria, but this is an easy way too. And what I'm going to do is say modify. To modify, you can go to the modify button here up top and say members. And the modify just looks exactly like the draw new members. Just make sure you click the use button, and then we can select section sets there and choose handrails. And I can choose this apply entries to all selected members at the bottom of my screen. That makes sure that I apply handrails and the use checkbox on to everything that is selected in the background. Say apply. Let's check it out rendered. So we double check that. It went as a pipe. We can select everything now. We can see that we have everything here turned as the way we want it. One of the things I noticed, though, I just did here is what we can take a look. Let's see. Okay, so we're all set and ready to go for this. So all I can do now, I'm ready to go and import this into Reset to my tank model. So I can do is save this model. And I'm going to save this here as stairs, just sort of any old name that you'll remember, and I'm going to save it to a spot I know. It doesn't matter where I save that as long as I have it saved. I'm going to go over to File and then just switch back to the tank model. Okay, once the tank model opens, and you'll notice once we start building these big plate models, it will take just a second. We have 3,280 plate members, so plates and members. So, you know, it's just a second to read things in. And of course, by sharing my screen doesn't help, but we do get it all in here. So one of the things we've got all set up, what we're going to do is we're going to start by importing that stairs. So I go to File, Append, and when you're in the model, you want to bring the model into, or import would be another word for it, but we have that there. Append, we can go in straight to pull that model up. It's got to be a RISA 3D model, and I can say Open. And what it does is it appends this model to select, bring this in. Now, one of the cool things about how this comes in is it unselects the rest of the model and just selects this portion of the model. So if I needed to shift it, mine actually works out really well. It's going to hit at all the locations I have on my tank. So I don't need to shift it at all. Everything looks like it's copacetic when I just rotate this. But if it wasn't, I could move it around using my move command. I could copy it if I needed to, things like that. That's all done for me when I make that selection. One of the things that's important that we've got here now is we are just selecting that stairs. So what I want to do is I'm going to save the state. This is called Save or Recall Selection States. If I click on that, I can say Save this state, and we'll call it stairs. And what that means is that it's going to be able to remember just this selection. And what I'm also going to do is reverse the selection and just select the tank. And I'm going to do another thing like saying Save the state, and I'm going to call this tank. So now, when I want to work with one or the other by themselves, I can use the selection states, and they're there remembered for me. This is going to be a really, really crucial thing for when we work with the results and looking at things, identifying things at one at a time. Okay, so now that we have our tank only, I'm going to do is I'm going to click the lockout button. And you'll see here that staircase, even though the selection state says it's not selected, you can sort of see it in the gray behind there. Locking it gets it rid of the selection and out of viewing. So you don't by accident click on it. So if I lock that out, now I have a little bit, and you can save that selection state if you want it with it locked out too. But I'll keep that just as the way it is. So what we want to do here is we're going to add some loading to this. And the way we're adding loading is we're going to be adding loading to the surface loads here. So what we can do, let's start by doing some layered loading. The first thing I can do is I'm going to unselect the entire model. And I'm going to use my criteria to help me guide me to just this lower 7 feet of this tank is what I want to start by loading it. So if I go over to coordinates and I look here, I can choose a maximum coordinate of 7 feet. So it's only going to select everything that goes up to a maximum of 7 feet. I can say select the items, say OK, and everything else is not selected except 7 feet high. So everything below 7 feet is now selected. That helps me identify just that lower plate level. So now I'm going to come into my Apply Surface Loads, And I'm going to apply surface loads. Now, it wants me to apply surface loads in the lower X, Y, and Z, which means the local axis, or the upper X, Y, and Z, which is the global axis, or I can do some projected loads or some temperature loading. So what are we going to do? We want to actually do some surface loads. I'm going to close this down here, and I turn my local axis on, and we want to do some surface loads as a pressure outward. So what we can see is the best way to do that is using our Z local axis. And if I rotate this well enough here, you can see the Z local axis is my outward load there. So what we'll do is we're going to go back into our plate surface load and give ourselves maybe, now we're in KSF. I'm going to actually switch it over to PSI, and I can just quickly jump into my dimensions and shift over to any of the type of dimension I want to see. So maybe PSI is a good one to see. And then when I click back into my surface loads, I now see PSI and maybe 2 PSI, something real small here. We'll just test that out and say apply to all selected plates. So now I have 2 PSI running around my lower portion of my model. Now I want to do the next portions, and I easily can do some selection states and things like that, but what I can also do is just invert the colors there. I'm going to turn off those plate local axes. They're sort of distracting, so I just say none. And what I'm now going to do is just going to say, now I'm going to unlock this and lock it one more time, and I get rid of that lower portion. So now I'm just looking at the top portion. Again, I'm going to use my criteria selection coordinates and type in 14. Oops, let's see. We have to unselect everything first. Then we're going to do that. Click on 14. And now we're going to select just that lower portion. Okay, and then we're going to apply that one more time. Maybe a little smaller load up here, maybe let's see, 1.6 kips, and that'll be applied there. And we can see they applied it to each plate. And I can now just reverse the colors one more time. Selected state goes on the top, and we'll do it one more time. So it's pretty easy to be able to put that in. Just drop it right on there, and we'll just put dead loads for now. Okay, so I'm going to unlock the whole model. I'm going to bring it back again. We see we loaded the entire tank. I'm going to take that loading off so we don't have to get distracted by all that loading. And now let's add sort of a cone on the top of that tank. So maybe somehow we need to be covered but not completely covered in from the elements on this tank. So let's put a cone on the top of that. So if I click on the high-level generation tool one more time, and I scroll down here, I can say cone with plates and click on that. Just like we had seen with the tank, we can put it 0, 0, 0. For ours, we're going to actually locate our cone at 20 feet, which is at the top of the tank. And we're going to let it go around 360 degrees. We want to definitely make it the y-axis so it matches our current tank. We'll have our start radius be 30 feet. So it's going to go all the way around the exterior of that tank. But we don't want it to close at 10 feet. Maybe we'll close it at 20 feet. So it doesn't actually go, we're going to have still some open air on that top of that tank. Okay, so the sweep increments, that's going to be really important that we match our sweep increments. But for a second here, I'm going to say 30 sweep increments just so we can see why that's so important. And then we can say axis increments will be 10, and we say a 1-foot increment there. We're going to all use the same type of members we had here, so arc members, and we'll change it to the axis members just like we had. Maybe this plate on the top will be just a little bit smaller. Maybe we use a 1/2-inch plate, and I'll say OK. And when we zoom in, as soon as it generates, you can see it does select it for us. Now, one of the problems with this, let's see why this is so important that we match these up. Plates are going to transfer their loads at their nodes. That's kind of the most important thing I can ever say about plates. And so what is happening with this model, if we did it like this, we can see that we'd actually be transferring these plates on the top directly into the middle of a plate. And what happens there, and we're not connecting along, these are not submeshed properly to each other. So what we see here is a really good picture. Let me show you in our help menu. If we go over to plates, and I go to design tools and, modeling examples. I'm going to just scroll down and show you what happens when you start applying some load to this. And this is kind of a really good picture here. It's called plate connectivity problems. When you start applying loads and things are not attached properly, what happens is that the actual plates can disassociate from each other and start to pull or actually deflect into each other, not accurately. So that's sort of the big reason why we really want to make sure that this is lined up properly. So when we use these tools, or anytime we're modeling with plates, we need to make sure that they actually line up from node to node. So the corner of this top plate has to land on a node. And you don't want any intermediate nodes along the distance of that plate because it's not connecting at all. So like I mentioned, it's so easy to do this that you can unclick that, just undo it, and then what we'll do is we'll go right back into this high-level generation tool. It will be all remembered. We'll just correct our little mistake there, which was 30. And we're going to put 80 increments just to match the tank we used before. Say OK, and now we can see that. We zoom in a little closer, and now everything lines up properly. Okay, so good, even if you're not using some easy increments like that, you're going to want to make sure you start submeshing things and working around them to make them line up properly. Okay, so once I have my top of my tank on place, what we'll do is we'll put a bottom of that tank on there too. So I'm going to go ahead and go back into the high-level generation tool, and I can scroll down and take a look at the disc there. This is a circular disc. Okay, this is a really important tool if you're trying to build a circular model with plates. It's real hard to model that, and what we've done here is given you a great starting point, even if you had to come in and modify it. But what we'll do here with ours is a 0, 0, 0, and what we'll use also is our same rotation axis. We're going to use our radius as 30 feet. Okay, the quad increments there. So what we have here is you can see that each quadrant, okay, so 4 quadrants for a disc, how many we're going to break that down into increments, or how many little plates increments do we want per quadrant. For ours here, we're going to do 20, right, because 20 is going to be 80 divided by 4. We're using 80 increments everywhere else, okay? So that's giving us a 20. And then we also have is radius increments here. So you can see this is the radius, and how many increments along that are we going to break it up to. And for ours model here, we're going to have 20, okay? And then we're going to come in, oops, let's see here. Sorry, I actually started typing wrong here, 20. Our radius is going to be 30 feet there. So 30, 20, and 20. So our quadrant increments and our radius increments are 20. Let's give it a little bit of a heavier duty steel, okay, so maybe a 1 inch. And then if you want, this is kind of a neat tool, you can change your prefixes, and I never really do, but one of the reasons why I might is to say to myself, hey, this is the base of the model. So if I ever need to find these nodes for any different reason, maybe I'll call this B as my prefix, joint prefix. So it helps me identify which is what part of what. So I can say OK, and then it will place in that disc on the lower portion there. Let's zoom in real quick and see what I was doing with that prefix by turning my node labels on and kind of zooming in, and you can see that each one of those node labels for the base of the plate has a B as an indicator. Okay, so you've got the tank here. We're showing all the different portions. One of the things I like to do at this point is to save this base portion as a selection state too. Okay, this will be an important selection state for us to look at for when we go ahead and actually look at results. You can see there's a little square in there. So what we've got, let's go ahead and actually say save and recall selection state. Say save, and we're going to call this base. So as I see here, I've got now stairs, tank, and base, and I can jump between the two, retrieve them, and we can see the different states there. Okay, so with the base, though, I'm going to jump back to the base for a second here and say retrieve. Now that the base, I'm going to apply some loads, and I can just click on, if you ever lose that top bar, it's real easy. Click on this little pencil. You'll come back again. And I've got here, I'm going to apply surface loads to the plates. Here I'm going to do, now the important piece we mentioned, we were looking at local axis. This piece actually is just a little bit different than the local axis, and you might have learned this here by trial and error, but I already know here the Z is actually up in this one, okay, where the disc lays it out. So what I'm going to do, I'm going to turn off that local axis so it doesn't distract us, and I'm going to put in now my magnitude of my Z direction, but it's going to be a -2 because we want to actually be in the negative Z direction for that local axis. So I'm going to say apply, and now I can see that I'm loading all of those plates vertically down. Okay, so there is going to be some sort of a default with those high-level generation tools always. You just want to sort of just take a quick look and double check it, and then how easy is that with our plate generator, our plate detailer there. So now with the section sets here, let's start. We're finished with everything else on the top of the model here. We've got a staircase. I'm going to turn some of that load off so it's not so chaotic. We've got a staircase running up our model. We've got some posts supporting that staircase. But supposedly here in this model, let's say that we are actually going below this, maybe even subgrade, because we still sort of supported these higher up, but maybe this is going even below. So what we're going to do is add some more support to this model. So what we'll do starting out is create another section sets to help us getting started with that. I'm going to come in here and I'm going to enter in we'll put like a truss system in here. So I'm going to call it a truss support. And then I'm also going to call it a webs for my truss webs there. And then I'm going to have some full supports there called columns. Okay, so starting with let's close a lot of these windows, getting a little bit too busy. Starting with our truss support here, what we can do is we can click on that, and that truss support is going to have to be pretty heavy duty. It's going to be supporting a lot of the load. So I think a tube would be something I might want to use down there, and it's going to be a pretty decent sized tube. Let's call out, let's use a 12 by of some sort. Okay, so maybe a 12 by there. I'm going to say okay on that. The webs themselves here, maybe we'll match it. We'll use the same type of 12 by, at least the same thickness, so it's easy for us to connect those. The columns, let's use a wide flange, something kind of decent with that wide flange, not too big, but maybe a 10 by of some sort. So let's come in here and say maybe a 10 by 54. You can say okay. All right, so what we'll do here is we'll set this up as the truss support we'll use as tube. Make sure that we set these so we get the proper design list to tell us what we're using properly there, wide flange, and I'm going to change my materials to be some tube shapes, and here are my columns. Okay, so once we've got all that in place, now here what we're going to do is create sort of that truss system below the model. So I'm going to start by using the circular arc again. I'm going to click on High Level Generation Tool, to click on Circular Arc. This time here it's going to be 0, 0, 0, but it's going to be actually drop below there that I'm going to create this. So I'm going to actually put this in as -4 feet. We're going to actually have this supported below. So I'm going to go down by 4 feet from the base of this tank, and I'm going to use this arc to go around the entire tank. So it's going to go 360 degrees, and it's going to be at 30 feet. This is radius arc radius. And then we're going to use here 80 increments, okay, just like we're matching our entire tank. And then we'll use our axis members there. Let's see, yeah. So we can use let's use our arc members to support that, okay. Actually, sorry, we have our truss supports, it's brand new section set that we just created. So if I say all that, I lay it out, I can say okay. And what I get here is now just a selection of what that lower portion is. And we can see that that is our tube shape. I can just render it real quick and pop up. That's our tube shape, our 12 by. And what we can do is copy this directly down by -4 feet to start creating our truss. So I'm going to say -4, and I'm going to say apply. And we'll just select copy the selection there. And I'm going to shift it back out of rendered. Sometimes looking at things rendered is helpful, and sometimes it's a little hindering. So what we'll do is just select a couple of these nodes, and I'm really going to build sort of a truss system and sort of verticals and some diagonals to help us brace this area. So what I'll do is click on the Draw New Members, and we'll say assign a section set. Click on here. I'm going to choose the webs. Those are actually going to be what I'm going to use for both the verticals and for the diagonals. And I can click this directly across there. If I click this directly across this point here, it's actually going to pick up that internal joint. I don't need to break it up. It's really up to you on how you want to model that. I like to use the least amount of members as possible, especially when I'm having a large model like this. So I really will try to just reduce that by drawing things directly across and using what we have called physical members turned on here. And that means that it's going to pick up that internal joint for us. Okay, so now that we have all of this put in here, I really need to copy it all the way around. It would be a lot of work for me to actually be able to do that and draw all of this in. So the point here is to make the least amount of work and the most efficient here. So what we'll do is we'll just select use this portion of what we need there, and we're going to copy and rotate it around the entire model 360 degrees. So I click on Copy Rotate. And I'm going to have it set up exactly as I have here. Only thing I do need to change is that the y-axis still, it's going to be 360 degrees, and it's going to go around not 80, because we can see here 80 would bring us around twice. It's just 40, because we're actually using 2 plate lengths for us here, so it's going to be 40 increments. There's no loading, but we can just say apply, and it's going to go around the entire model there for us. And we've got that all set up. One of the things we've done a lot of work on this model. It really would be helpful for us to do a model merge at this point. We have a lot of plates. We have a lot of probably some things that we sort of overlooked when we copied and done a lot of these rotations. So what I'm going to do is I'm going to go to Tools, Full Model Merge. I'm going to merge all the crossing members. I'm going to merge anything here. We can do inactive items if there were any, and just say Apply. And we're going to run through, and it's going to merge through all of my members, joints, things like that, and it's checking everything if there's any duplicates. And we see that there's 126 duplicate members. It picked that up and eliminated that for us, so we don't have any problems there. Okay, and those are ones that are just directly overlapping, which does just happen. Okay, so now what we'll do is we're going to select only the lower portion of the model, okay, and we're going to lock out the top. So I'm going to go ahead and take a look here and just select this lower portion of the model. And I'm just going to lock everything else out here. Okay, so we just have a clean model to take a quick look at. And we can rotate this. I'm rotating things around with my mouse, by the way, and you can just sort of hold the Shift button and use your mouse to scroll around and find things that in a three-dimensional model, just like I just found, sort of hang out there and you can't see very well. Okay, so what we'll start to do here now is draw in that base of that model, or the column. First thing we'll do here is I'm just going to select a node. I'm going to go to isometric view here real fast, and we can pick up a node here. Any node really will work. I'll pick up that one right there. And what I'm going to do is also grab the center of this model. We're just going to copy this area down by, and I can see here, I'm going to just locate my center. Sort of easier said than done, of course. 0, 0, 0, I'm very close. And there we go. There's my center, 0, 0, 0. And I'm just going to unselect everything, reversing the selection there. And I'm just going to copy those 2 nodes down by 10 feet. So if I just say copy, -10, okay, let's just say apply. And now that one's kind of hidden because there's so many, but we will find it when we try to draw. You can see when you hover over things, you'll see that very easily. But what we can say is draw new members, and we're going to draw in those columns. Okay, so I'm going to just click on this and draw in a column, and then I'm going to click on that and draw in a column. Okay, so I have those 2 columns in place. I'm going to give myself some boundary conditions. I'm going to fix them and just say apply. Okay, so you're wondering why I just drew in one in the center. What I'm going to do also, again, I'm going to select that center one, and I'm just going to copy rotate this one around the model. Okay, so instead of actually having to go figure out where, we do know we want them equally spaced around that tank. So what I'm going to do is come back into here, and I'm going to copy rotate this 360 degrees, but now we're going to change the number of increments to be 10. So if I say apply, it draws them in at 10 feet. Now the boundary conditions get applied for me automatically. Everything is automatically placed in there for me. One of the things I do need to do is draw in a little bit of support above the tank there, because we are seeing here a very large tank. So I'm going to draw in some wide flanges above that. What I'm doing right now is just sort of selecting that node directly above the columns, so that I have sort of a nice load path here. If I probably wanted to do, I could maybe make these verticals a little stouter directly there, as they are going to be kind of right in the midst of that load path. But we'll kind of skip that right now. So what we can do is just select this upper portion, and I've been using section sets all the time, but some folks might not be really comfortable with that. So let's try just drawing in a normal member and seeing how that works. Pretty much the exact same thing we've been doing, hot rolled, but instead of saying selection sets, there, just choose assign a shape directly below that. And then what we'll do is we'll pick a W14. Let's go up to maybe a 14. We'll start by 14 by 90, or how about 99? Okay, so we've got a 14 by 99. We'll choose our wide flange design list, A992, and it's going to be a beam. Okay, so we can draw that in. Oops, it looks like I missed one node to collect to. Okay, so If you ever sort of oopsie daisies like I just did, without having to go back and remember where you were, you can always right click and say recall last dialogue. And it pops me right back where I was, and I can just start drawing right back again. Okay, so I'm going to draw those across. Now the way I'm drawing these here, they're continuously across. What I would need to do is I would need to add, if I want them to be attached in the center, which makes the most sense there, is I need to do a model merge. There's another model merge here, perform a model merge just right there. And this one allows you to do only selected items. It doesn't really matter in our case, but I'm going to say apply there. It's going to add a node in the center. Okay, that way what's going to happen here is I've got now a node right at 0, 0, 0. Oops, can't show you. There, it's a little too tight. But now I actually get a node in place. Okay, so now when we come back to our full base of our model, we're all set here, and we can look at the entire model again on our screen. I'm going to unlock everything, and I'm going to show it all back on my screen, and I'm going to render it and show it in isometric view. And we can see here we've got everything in the model. We've got the base, we've got some supports, we've got our truss system on the bottom of this model. If I kind of circular go around this model, you can see all sorts of things happening in this model so far. We could have added many different things to help support us in different ways, but kind of limited by time here. So next thing we'll do here is we'll jump into load combinations. If you open up the load combinations, I'm going to first of all shut this down here. Rendering here is a great way to look at the model, but it does eat up a lot of your speed there, so we're going to slow that down a little bit. And we're going to go back into here into load combinations. If I click on load combinations at the bottom of my data entry toolbar, the top here LC generator pops up. If you click on LC generator, you've got this is a brand new load combination generator. If you haven't noticed, I'm using version 9.0, which was just released, so it's a little bit different. If you haven't yet received it, you should be receiving it any day now, or we're sending out the releases right now. So if you're up to date to get the new version. And the new the load combination generator is just a little bit different. It's going to show us here we can do wind loads, seismic load and gravity a little bit separately. And what this does is it allows you to break up. I'm going to pick up the IBC ASD. And if I have roof live loads and snow loads or rain loads, it's going to allow me to create load combinations for that. If I want notional loads inside of mine, I can put in notional loads in either direction. I'm going to say no for those. For my model, it's just going to put in the dead load and the live load. But if you go over to wind here, you can see that we have X and Z with eccentric, with quartering as well. You can also add if you had turned on your notional loads, you can have those in there as well. You can do seismic. With your seismic loads, you've got a lot of different options in here. Okay, so, but I'm going to leave that out right now. So only ours that matters here is going to be our dead load and our live load. Okay, so we've got dead load and live load. I'm going to leave P delta off for right now, but we are using the 360, the solution, the code 36005. So when we finally do the solution, we will want to turn that P delta turned on. But this is our initial design, so we will be okay to just leave that off. And I'm going to do is say solve the solution. I'm going to choose the load combination with dead and live load, and we'll run that solution here. So it'll just take just a second or two to follow through all the different load combinations. Actually, we just did one single combination, but what it is, we've got several thousand of my different loads applied on those plates. We can see how many loads are going through. But and what we'll do here is we're going to look closely at what happens once you have this solution. First thing we'll want to take a look here is this is, like I mentioned, it's just going to be a warning that says that we did the code check without P delta turned on. It did not meet the standards here of the chapter C, but it's just going to be a warning, okay, not an actual error. So I can just say okay. We see here we got 3,600 different surface loads on that. But what we've got on this model here, now to quickly take a look at what we are looking at, first of all, how did our members do? If we look at our members on our results spreadsheet, it's our member design results that we really want to first take a look at, okay? And it looks okay in the very beginning, but let's take a look and click on the UC Max, and what I first do is I say sort this whole spreadsheet and look at it by max to min. Say okay, and I can see I have some failures. They're a little bit high, 1.4, okay, not real bad. I'm not failing only by 40%. It looks pretty good. But let's take a quick look at the model itself. A nice, easy way to take a look at the model without the plates from the first thing is that so we can go to the criteria tool, go over to plates, and just say unselect all the plates, please. You don't need to put any information in, just say unselect plates, and all the plates go away. Okay, it's sort of still, we have members everywhere. We can also take off those joints, so we don't have to see those joints in our way. But now we have just our members showing. What we can do now is go back into the plot options, and we can take a look at the members. Under color-coded there, we can see what we've got here is we can check unity, and we can also check unity here for bending on our labeling. So if I say OK, all of a sudden now it starts to show me the color coding. Now the numbers are a little too complex for this type of model, so what I'm going to do is turn off my labeling, just look at the colors. So now we can really identify what is failing in this model. Okay, it looks pretty blue to me, which is a really good sign. That means that we're at 0 to 50% on the code check, and that's on the top right corner. At the bottom left corner tells us that's load combination 2 that's running behind our scenes there. So what's failing, like we said actually when I was talking about this, is that probably that failure mode is just directly from the tank to the vertical to that column. So, an option here is to size up these webs, but that almost seems a little bit unnecessary. What I might suggest doing, although I might not do it we don't really have time to do it today here, but I would probably do is create a different section set for verticals directly underneath these supporting beams. And those would be the ones that sized up, not the rest of them, okay? That would be probably my step. Or, you don't really need section sets. You could just double-click and go over to the design, the properties tab, and instead of using a section set, switch over to the shape and pick that shape that might be the best shape for you, okay? And I would go from there. But the section set tends to be a pretty easy and quick way to do it too. So once you've got your members identified here, let's take a quick look at our results, and we can turn back onto our plate members. I'm going to look at how our plate results look at. First thing here for plates don't have a code check, okay? So when we were in design results, we were looking at something called UC max, which is the unity check, okay? And that's because we're comparing that plate to the AISC code that we selected right in the beginning in global parameters. Okay, the plate members don't really have a code check per se, but what they do have is plate stresses and plate forces, both of those. So first of all, let's look at plate forces. And what we're looking at here is a one number per plate. Okay, so what the actual plate happens in the plate analysis is you have 4 Gaussian points inside of a plate, and this one number represents the average of those points there. So you only get one number per plate, which makes it really important to make sure that your submesh is adequate so that you caught what you needed to do. For steel, if we're looking for stress points on this, we may want to make sure it's real submeshed, real tight. For concrete, where we're more of a blended average, we might not worry about what's happening on this one tight plate. So submeshing might be not as crucial, and that we make it real small and fine. We've got here is also, we can look at the bottom of the screen. If you ever have questions about what you're looking at, that's the first spot you want to look at. So you have QX, which is the transverse shear. You can see here you've got in the different directions in the local x-axis, and you have it in the local y-axis. You also see your moment in the local x-axis, MX here, and then MY. And then we have MXY, which is your out-of-plane moment, or we also call that the warping or twist. There, and you also have your forces in the x direction, normal to the local axis there, forces in the normal to the y-axis and the xy. Okay, this way, the best way to understand all of these is to also open up a quick picture here in our help menu. This is going to be for our plate forces, and we can see here showing what the plate forces look like in this diagram format. Plates are a little bit different here than beam theory, so you will want to sort of study this and make sure you understand what you're looking at, so you really see what you've got there. The other one that we have is plate stresses. Again, this is going to be, not solid stresses, but plate stresses. This is going to be here given for the top and the bottom, so you have the T and the B, and you're going to get these stresses here, just like we see in the one number per plate. So you have sigma 1. You have listed sigma, I'm going to span this here, sigma 1 and sigma 2. You get tau max, and let me open just a second here. You can see a little bit farther about what we've got available here. Okay, so sigma 1, sigma 2. tau max is created here by using this equation to find that, using the sigmas. And you also have the von Mises stresses that are using the sigma values there. So you've got all of that listed out here for you in the spreadsheet format. This is obviously a really great resource, but you may want to look at it a little bit more visually. So the way we could do things more visually, let's turn on some of the forces here. So again, let's see, another way we can do just like we did before is everything is unlocked, everything should now be selected, and what we can do is we can unselect all the members. So we can go back into the plates, go to members, just using the criteria tool, say unselect members, say OK, and now you just are looking at the plate elements. A way to get rid of everything else on the screen is to lock it out. I'm going to take off my boundary conditions so they don't hang out down there. Okay, and now we're just looking at the tank model with all the plate elements. If we go here, we actually have what I showed you before here, these cool little icons that are now in here. We can display things like our sigma 1 top. Okay, and that shows me, if I scroll in and see a little bit in this tank, let's do a little, sorry about that, we're kind of rotating around and it's hard to see. Okay, so we've got all sorts of things on the, looking at just the sigma top. Let's look at just the base. Well, maybe we'll have anything interesting to look at here. Mostly it's the base we're really looking at. So one of the things we can do is retrieve that base state, and then we can actually see that. There we go, much easier to see. So we can scroll through this different tau max and all the different values we have here. This is really just as easy as if you're going to plot options and looking at plates members here and turning on the color fill, contours, and then your contour control. Okay, but the icon makes it a little bit easier to grab. You can also show our forces, so we can maybe take a look at our QX in here, our QY, for example. If we look at our QY here, we can see that we have different values in here. When we want to be in here, actually, another piece that's really important, let's take off here, we can see we have plate shear Y kip per foot running on here. And this is actually what gives us the color coding here. And as we look at these contours, it's a really good thing to see here. So there's some stresses happening in here. And if we want to look even closer at these stresses or exactly what's happening at a certain area, what we can do is use a couple of our other tools. The first tool we might want to use here is something called our internal summation tool. If you click on that, it looks like a summation at the bottom left corner, and it will be available here when you have a solution present, and it will be here. You can click on that little icon there, and what you get is a little saw that shows up on your screen. That saw, what it's going to be asking you to do is click in 2 points, or what we call a cutting plane. If you click anywhere, you can click any node on your model. You can see that first node I clicked, I get sort of a red line. The second node I click, I actually can click on that second node, and it creates a cutting plane. That cutting plane allows me to summate along this line. So what we're doing is summation of forces along that line. We can see that we can have on the bottom of the screen, as I scroll it up and down, you see that the forces actually change. And what you can do is hover over maybe a maximum point that you're of interest, and you can click on that. And what you'll get is a resultant forces and moments. You see F1, 2, and 3, moment 1, 2, and 3. Okay, and those summation of forces are a brand new axis. It's a local axis. And what it is it's sensitive to what's being displayed on the screen and how that is actually being displayed. So if we were actually in isometric view or something, it would be actually affected by that. So you want to look something like a flat plate here. You want to look at it straight in the XY, or if we're looking in the XZ direction, okay? And it cuts that new plane here. Local 3 is always going to be perpendicular to the current model view, okay? So you've got that local 3 direction here. You've got local 1, which is going to be in parallel to the AB click, which we had A and B, so we can see local 1 is in parallel to that. And then the 2 is going to be defined by the right-hand rule, so you're always going to see it out of the plane using your right-hand rule. Okay, so your geometric center is then also selected here based on that where I clicked. That third click selects that location, and we also get a vector normal to the cutting plane. This is really useful for finding a specific place on that. And what this is really actually using is our corner forces. Our corner forces can be displayed here, so we can actually see our corner forces. I'm going to go back to wireframe so you can see this corner forces. And each plate has a corner force. Okay, in each direction. And you can see if I scroll in a little bit, we have actually equilibrium coming around each corner force. Oops, I don't want to see any contours because that's distracting us. Okay, so each plate, this is a single plate here, and it has a corner force on each location, and that's how we summate that force along that internal force summation tool. Okay, so that's the internal force summation tool is a really important tool to use, but again, make sure that you know it's based on what is selected. So if I had other things selected in the model, it's going to cut in an infinite plane along that whatever is selected in my model. And it will also make a difference if I made a thing like slanted, like an isometric view. That's going to actually give me different results, okay, because you're actually basing it on a new local axis that you cut. Okay, so the other piece here is now that we've looked at our internal summation tool, we have another tool. I'm going to turn off my local axis because it's going to be a little hard to see. I'm going to put my contours back on. I'm going to say apply. And if I look at this here, I'm going to say okay and get out of this. What I can see here is that I have these contours, and they're giving me rough numbers, but it may be a little hard to identify exactly what's happening in here. So what I could do is I can use this contour display tool. And what this does, it allows me to go anywhere along the distance of this model. So I can sort of pick any node. It has to be on a node, but I can click on anywhere else. It doesn't have to be in line, but it could. So we can see this one here. And it actually does is it shows me the contours along this new line I drew. So it's like a cut through the model and shows me exactly what the contours for this display is what I'm looking at. Once I have that cut here, this is also a really cool tool, but hard to see directly on top of other contours. So what I can do is right-click and say Contour Display Tools, and then I can say Show a Detailed Diagram of that. And you see that it now shows me step by step. I have an interactive drawing here of what's going along this contour. So not much is happening in here, lots of happening activity on the edges here, lots of shear in this model here on the edges of this contour. Okay, and you can cut that anywhere you want through the model. So maybe you get more, if you're submestrial tight in here and you have a lot of interesting contours that you want to look at in here, you may want to zoom in close. And my model sort of real hard because we're sharing here, but you can see now I get to see a lot of different things happening along these contours. And again, just click there and say Contour Display Tools and Detailed Diagram of Contour Cut. And we get to see that a little bit closer there. So you've got all of that information all ready to go. The last step, of course, is to run through your members and start to resize things as they get better. Our suggested shapes is the spot that I would do that. If I click on my results toolbar, let me just show you how I got that again. Let me pop out to the entire model one more time. And if my detail data entry is always on there, hiding with the D button. I'm going to turn that off, but the results toolbar is always available when we have a solution present. And the suggested shapes will tell me, hey, this L5x5 double angle 5x3, was maybe better by a 3x2. Okay, so we didn't need it as large. Maybe that 12x is not working in some spots, so let's change that to a 13.5 for my WT. And so it'll give you the controlling actual member that controls. So some of this actually can be misleading. It can't really always run by this. For example, our stringer. We need our stringers to be, and our treads here, to be at least 10 inches there, right? We don't really want to go too much smaller than that. We picked that size on purpose. So they're going to select a 4x. That's probably not a good idea. So I'm going to unselect things like that, okay? But what I can do is run through and say, okay, pick some of these, but don't pick others. I don't really want my post to be that small, 2.5 inches. My pipe was chosen specifically so you can grab it at 2 inches. So I can go ahead and do that, and once I've gone through here, I can right-click and say Solve Again using the suggested shapes. Once you solve it again, you can say, it's just going to give us a warning. It's going to rerun the entire stiffness matrix using all of the different members there. It's going to go through a solution, okay? And what we're going to get now is going to get new design lists there, new suggested shapes based on what the program thinks might be better. But also we're going to find that sometimes maybe things got worse because we sized other things down, just because you are fully running the full stiffness matrix 100% again. Okay, so once we have the solution, I'm going to try to get out of here. We're running a little over on time. But what I want to see here is, again, we can look at our design results to see if we have anything better on this. I'm going to sort it. And, yeah, so now we're 12% overstressed on about 8 members we've got and some ones that we'd have to work out. okay? And there are still some suggested shapes. Of course, there are the ones that we remember that we still have will not allow it, but we could start going through one by one now. We could even identify these are the ones that are the problems and start going into those and specifically change just those single members. Okay. The other pieces for here, if we wanted to investigate, hey, what is happening on that member? There's a detail report. If you're not familiar with that, you can actually click on that right from the design results. You can click right on the detail report, and you can see why this is actually causing a failure. What's the issue here? Okay, and why do we have? Let's take a look at that interactive moment from my detail report. Is there something happening here? What it does also give me is by code check information and where exactly that is happening at 0 feet. I'm using equation 1-1, H-1-1B, so I can see, okay, so 0 feet looks like I do have a kind of a lot of maximums at 0, which is this lower portion here. And so that's probably what's happening and why I'm failing. But then, so maybe I just need to size up. There's nothing else I can do for this model, okay? Again, one of the last pieces we didn't really address, too, is into something I shouldn't really neglect, is that you really do want to go into your members and assign your unbraced links, okay? One of the more important things that we did is we ran using physical members, and that was something we did here at the bottom of the truss. I'm going to turn all those members on. And when we drew this member across, directly across that member, we had actually drawn it and it was connected at that point as full member. It is braced by some degree here, and we would want to go in and change our unbraced links, our LBYY, our LBZZ, LComp top and LComp bottom. We would want to actually adjust that so that we account for the bracing of these other members coming in. Lastly, once you're finished with the entire model, okay, you can unlock everything. We can take a look back here at the entire model. We can focus on the entire model by clicking on that. We can go ahead and print everything we want to print by going back into the print a report. And here we can either print the picture of what we're looking at, which is a really helpful tool when you're looking at your model, but you can also print a report, and you can come into print a report, and you can choose all of your input and output, which is very rare. You'd want everything. What I would recommend is going one by one and finding the things that you want for your model. So maybe basic load cases. We didn't have any concrete in our model, so we probably would skip concrete information or cold form. We would want things like we had hot rolled in here, okay, and we had different pieces. We didn't put any footings, but we would go through here one by one and pull off what we would want in our report, and that would be how we would customize a report for our model. Okay, so in conclusion, let's talk a little bit here. Final things to consider: there are no limits in the 3D modeling. Consider different things. So I made this model here, and I didn't quite know how to lift those stairs, but sort of brainstormed and thought to myself, how can I get these stairs to move up automatically without breaking my neck over having the geometry, okay? And I sat there and worked on Excel and brought it in. Also consider importing DXF or Revit structure. If you have a really difficult model to work with and you already have something drawn up in either of those programs, just import it. You can even import just points and connect those points. So try to be creative is the point. Don't forget that you can use the tools available, like the high-level generation tools, but you can sort of work with those and create whatever type of model you need to. We have lots of folks building interesting models, and we see them all the time through support. But let us know what tools might be helpful for your model too. Definitely, if you are stumped on your model, and you can always email support@risatech.com, send us your model, and we'd love to see, at least it's always fun for us to see what you're doing out there and what kind of crazy geometry we get to see for the models that are coming out of RISA 3D. But maybe we have a good suggestion about how to do something that you just can't get done in there.